On August 6, 1945, it was quite hot, beautiful and clear weather in Hiroshima. Yes, Japan was at war, but life was going on the one hand. It was Monday, and it was about to hit 8:15. It was just when people were starting their shift that the children went to their schools. At the time, 13-year-old Shigeko Sasomori was about from ground zero, the point where the bomb was dropped. She was going to his school friends to collect the garbage on a street 1 kilometer away. He heard a plane. He raised his head and looked up the sky. The plane he saw was one of those bomber squadrons that strike fear into the hearts. It was a beautiful, silvery, shimmering, big plane. He thought, what a beautiful plane. From inside and started watching it. Then something started to float out of the plane. What she saw was an atomic bomb that will be used as a weapon of war for the first time in history. The bomb causes such great destruction and that the copper dome of the building, located just below ground zero where the bomb exploded, melted instantly. It had lost its vital properties by turning into simple carbon particles before the people in it could even understand what it was. There were no survivors in the 250-meter area when ground zero was centered. There was a lot of destruction in a much larger area, almost the entire city, and everywhere was reduced to rubble. When the atomic bomb dropped on Hiroshima exploded, 70,000 people died in just a few seconds, and by end of 1945, this number had increased to 140,000. So, how did uranium weight hanging only 63 kilograms turn into a bomb big enough to wipe a city off the map? How does the atomic bomb work? There are two main types of nuclear weapons. One works on the principle of fission, that is, the disintegration of the atomic nucleus, and the other on the principle of fission, that is, the fission of atomic nuclei. First, let's look at the fission method. Uranium dropped on Hiroshima or plutonium bombs dropped on Nagasaki are nuclear weapons that work by the fission method. In these weapons, when the decaying isotopes of heavy elements such as uranium and plutonium are combined together over a certain weight limit called the supercritical mass, they react in a chain reaction to produce a very large force. Bombs produced today are mostly plutonium containing. This high wealth of material is obtained from enrichment plants or nuclear reactors. Nuclear fission. During nuclear fission, the nucleus of the atoms disintegrates. For example, if the isotope uranium-235 is bombarded by a neutron, its nucleus splits into two unequal parts. To tell you in more detail, when a neutron is launched into an isotope of uranium-235, this means that the isotope of uranium-236 is formed. Since this core will be very unstable, the uranium core will break down immediately. As a result, krypton, barium, free neutrons and energy are released. This resulting energy is so great that the disintegration of a uranium atom can be more even a grain of salt. It is like a soccer ball taking the moon out of orbit. If the resulting free neutrons are directed to other isotopes of the uranium-235, the fission event continues in a chained manner. And when trillions, quadrillions of nuclei of uranium atoms are destroyed in microseconds, a huge energy arises and a massive explosion occurs. In order for the chained core reaction to occur, the medium must be at or above a level called critical mass. In other words, if at least one of the three free neutrons that occur when a uranium atom breaks down can be directed to other uranium nuclei, this will allow the chain reaction to continue and provide critical mass. This is also the method used to generate energy in nuclear reactors. But for an explosion to occur, at least two or more neutrons must be able to be directed to other nuclei. When this happens, the supercritical mass condition is met and the bomb explodes. To reduce neutron loss and increase the number of the fission, engineers designing the chamber in which uranium is located in the form of shapers with a minimum surface area. They also cover the inner surface with a mirror so that the number of neutrons participating in the chain reaction can be kept at the highest level. How does the hydrogen bomb work? Fusion bombs are much more powerful than fission bombs, since combining the atomic nucleus releases a much higher amount of energy than breaking it down. The atomic bomb dropped on Hiroshima was 15 kilotons strong. That is, this means a power equivalent to the explosion of 15,000 tons of TNT. But even Mike, the first hydrogen bomb to be tested in the world, was exactly 10 megatons strong. This, in turn, means a power equivalent to 10 million tons of TNT explosion. The power of a hydrogen bomb, as the name implies, arises from a thermonuclear reaction in which hydrogen atoms combine and turn into helium atoms. This is also the method that our Sun uses to produce energy. Nuclear fusion. A hydrogen bomb releases energy by combining two isotopes of hydrogen, called deuterium and tritium. A hydrogen atom consisting of an electron rotating around a proton is called a protium. It is the most abundant isotope of hydrogen in nature at 90%. But deuterium and tritium isotopes have extra neutrons in their nuclei. When these two isotopes fuse and form a helium atom, a large amount of energy comes out. Normally, it is incredibly difficult to fuse the nuclei of two atoms. These nuclei have strong positive electric charges and repel each other. That is why hydrogen is used as thermonuclear weapons. Because, unlike other atoms, it has only one proton is easier to fuse. Nevertheless, the ignition and temperature necessary to start the fusion reaction must be very high. That is why the trigger used to detonate hydrogen bombs is not a dynamite, but a fission, that is, an atomic bomb. But an atomic bomb can produce the heat to fuse atomic nuclei. So, the explosion of a hydrogen bomb includes three different stages. First, a conventional trigger dynamite explodes, which detonates an atomic bomb. This dynamite detonates an atomic bomb and a hydrogen bomb with a high temperature, which is also produces an atomic bomb. Although the power of atomic bombs is limited, there is no limit to power of hydrogen bombs. The most powerful hydrogen bomb ever detonated on Earth is the Ved bomb, made by the Soviet Union. The Ved bomb is 1,600 times more powerful than the total number of atomic bombs dropped on Hiroshima and Nagasaki. In addition, the power of Ved bomb, it is also 10 times more than all conventional weapons and explosives used during World War II.